of the National Foundation for Energy Healing and the Science Advisor for the Spirituals for the 21st Century Project at California State University, Dominguez Hills. Dr. Connor is the author of 7 books. So, welcome.
I always get embarrassed. I always get embarrassed with the bios. You know, it doesn't feel like me I'm listening to. It's called Sweating Blood Gracefully. That's the real start. This presentation actually came out of a series of synergies, interestingly enough, from this morning. I was on a LinkedIn group talking with a bunch of people from American Military University. And it became very, very clear in the dialogue that we were having in LinkedIn that there was a huge disconnect on what's available in terms of the tools to manage big data and to do things with big data, and what is knowledge that's available within that industry segment. They just don't know where to go. They don't know where to get things. They don't know how to do the process. It's interesting that the process pieces, the challenge grants, were so evident this morning, because that was clearly the life cycle and processing was a significant piece. The information that I'm going to give you today is not approved by IBM. I have not asked for permission. So I am speaking for myself and through my own experience. The big data issues are very, very interesting. And they actually really start with the quality of the programming skills of the people that are out there. One of the single biggest problems that I found, and IBM has been doing big data since before big data was called big data, okay? We did big data in, 120 plus countries, simultaneously working with the packaged goods industries, for example. And this is back in 1990, 91, 92, all right? So it's been around that long. There are plenty of tools. But what I've seen as there's an evolution in the field is the computer programmers don't understand how to use the stack. And they don't understand how to optimize their code to write it in such a way that they're using the chip. And they don't understand how to port it. It's really frustrating for the end user, because that piece is lacking in the educational process. They don't learn that piece. That's the wisdom piece versus the instruction piece. The integration of that just isn't happening. The level of problem definition and understanding what they actually need to solve is a really big factor. The actual problem in the specific area, a lot of the time that people are involved in evaluating the big data process and bringing information to the table, the individuals who are the decision makers have no background. None whatsoever. Okay? You're going to spend your time raising the decision makers so they'll make a good choice. Very big problem. And your programmers need to know how to do it, and they don't. Okay? Correct hardware to solve a problem. Correct software to solve the problem. Intersection of compatibility between the hardware and the software. Cross-platform portability. Okay? It isn't any good to have the data if the end user can't read it. Big problem. One of the most common complaints that's out there. The end user needs do not get correctly defined because they're often defined by the decision maker who has no end user involvement. None whatsoever. Very big piece of the process. And the production of the reports, for example, in the military environment, the reports are standardized. They know how to read them. If you don't give them the report in the same form, they're useless. They are going in the trash. They are not going to bother. They don't have the time. They don't want to fix your problem as a programmer. They don't want to fix your problem as an application systems designer. They want to read the data in the format they need. Learn that format. Key piece of the process. Okay? This is a direct client quote. I don't care how your software works. I don't want to spend time with your software. I just want the data I need to run my business. They're not there to debug your mistakes. Okay? Don't send them the software that's buggy. Please, please don't send them the software that's buggy. Okay? No, it's not. But I have to tell you, you get Coca-Cola down in, 50 countries at once, it's a little bit of a sweaty day.
We had someone from Microsoft here.
I was not impressed.
I don't know. I don't like Apple much either, so.
Linux.
Aha! We have a flip side to this, and that's a poorly trained user community. Now, the kids that are coming up are used to social media. That's great, but that's ease of use. So if you're not providing an ease of use interface with a whole lot of icons that are doing the work for them, forget it. Okay? They don't know how to critically think through the process of solving their problems. My daughter is getting a master's degree. She's brilliant. She is. She went to Mount Holyoke. She got A's. She got full scholarship ride. She's brilliant. And she sat with her computer the other night and slammed it down.
Broke it.
Actually, yes, she did. The hard drive is toast because she could not get a piece of software to load, and she couldn't get it to load because the address stacking wasn't correct. There was an interrupt address problem. There was a conflict. We're toast. That's a very basic problem to solve if you know where to go to do it. But we're not teaching the end user that kind of stuff. Okay? We've got the incorrect people making the purchasing decisions. The decision maker may be a competent individual in their area of expertise, but their area of expertise does not translate. Area of expertise in one area does not mean you're competent in others. So getting the right people on the team to support the decision maker and provide input that's effective is extremely important. Okay? Poorly defined understanding of the real problem that they're trying to solve. Oh, it's the big one. And poor quality problem reports. I have to tell you what.
Because what you are saying, we never signed a contract in our consulting firm during 30 years that would not allow us to get access at least each week to the user, not to the meta user and not to the decider, but to the user, and should be at least one each week.
That's beautiful.
So I lost the half of the contract because the decider would not sign it. Okay, I lost it.
The other side of that is also the decider needs to have a clause that what you're bringing to the table for consulting work is actually going to work. It's going to interface and work. Okay? Because the cross-platform portability is not a guarantee, and that has to be a piece of the contract. I want to focus on the problem reports and tell you a story for a second. It was wonderful. This was one of my best end users. They were lovely, and they were a generic end user. They were not, super high-powered computer science person. And they were trying to port the data, and they had a huge amount of data that had to go up, be processed on the high-speed mainframes, and it had been working successfully for a month, and we were all excited, and everything is fabulous. And I get a phone call. It's not working, it's not working. Everything's the same, and it's not working. And they had moved across the street to a new building. They had a new server room. They had a new set of hookups, and there was no power turned on to the plugs for the servers. But everything was the same. Okay? That's consistent with the kinds of problem reporting that you're going to get. So a piece of the challenge is teaching your end users how to report the problems so that they can give you a good quality problem report. And if we don't teach our programmers how to talk, and yes, they do have to speak the English language or the Spanish, or the Portuguese. They have to speak the language of the end user. We have to teach them to speak to the end user. All right? All right, so how can you utilize the terabytes per hour that you're receiving? All right? You define the needs as closely as possible to match the business or the situation. You do data mining. There's always going to be more that you can use, as I was reminded this morning. Select the correct platform to do the processing. One of the biggest single problems that I saw was that people were trying to do it on a PC, and it couldn't be done even with stage servers. Okay? Could not be done because the processing capacity of the machines and the load balance wouldn't meet. All right? Very, very key that even your average programmer understand that process. They understand data storage, they understand throughput, and they understand how to balance load so that when their boss comes to them and says, what do I do? They buy the right machines. The machines exist. You have to buy the right one, all right? Understand the tools that are available and don't limit yourself to one company. Now, I wrote that politely. The fact is that if you want to do big data, the best stuff out there is IBM's, period.
What about
SAS is lovely if you have a relational database, and it's completely useless if you have object-oriented, and it's almost completely useless if you want to do extreme data mining.
They use tree methods instead of database methods?
They do and they don't. What's happening behind the scenes versus what you're seeing is different. They do and they don't. If they don't have a data map, they can't do squat for you. They can't. They're good at what they do, but they have a defined form. Okay? If you're looking at big data, you want to play both ends against the middle. All right? One is the problem you're trying to solve, and the other is what the end user actually needs. Because sometimes they're different. You want to build the fast platforms that are correctly sized for the environment. You want to limit the bottlenecks in the hardware. That's going to be a factor. You are only as good as your throughput. You want to talk to people in the purchasing and have them use industry specialists, and especially if you can use a vertical segment industry specialist. Speed, correct platform, correct form of the database. And in a lot of the new data, for the large data systems, frankly, an object-oriented database is better than a relational one. Correct tools for the analysis and the correct form of the report. You're not always going to be able to crowbar your data into somebody else's format. Okay? You can't do it. You cannot make your normal cell phone calls, if you're getting terabytes of that stuff crowbarred into a relational database. It's not going to work. You've got to have fully variable length fields. Understand the types of data that you're collecting, understand the tools that you've got available, and look at the types of databases that you really need. All right, so how do you determine a new corporate strategic direction when you're basing it on the data when you don't understand the shape of the data because you're getting too much data too fast to really evaluate it? The answer is you have to come from the problem definition. If you define the problem tightly, as you start to build the solution, the data shape will become apparent. And it makes a difference when you define it tightly enough. How long do you keep the raw data? How much space do you have available? Okay? And are you a pack rat or not? What are your processing speeds? What are your storage facilities? You know, how fast can you process to get the answers that you need out of the data? How do you define that? And then look at your data sizing.
I'm just curious, isn't it true that you can start approaching your problem and develop a beautiful theory, and then you can just look at the data for 5 minutes and see 10 things you didn't notice, and then you go back and define the problem, you see 10 other things you don't notice, and I think that happens very frequently even with small data, certainly with big data. So my understanding is defining the problem as an interactive process with the data, and you can't do it.
If you can use it as a starting place. I'm not saying use it as an ending.
My point is that it's great. You can't use it as a starting place. You'll fail. You have to use
You dance back and forth. If there isn't an interactive process, you're not going to be able to fully define the problem. But you have to have a starting place. So you define what you want, and then you start to look at the data shape. Okay?
Yeah, so there should be, there are a lot of philosophy here. We actually tried talking about sort of a taxonomy of analytics. So you're talking about the traditional BI, business intel,
That's right.
relational, et cetera. We moved from that to having to deal with all kinds of unstructured, semi-structured, and eventually into the multimedia. And what you find is, sort of to your point, you know how you used to categorize things, and now you go beyond that, and you start putting things into predictive models. So we're doing a lot more predictive and learning new predictions you can make. If you have enough of corpus, you can calibrate your predictive model by changing the parameters and the ranges of those parameters. And then the next level of it, of insights in it, is what we call, is a non-deterministic analysis, or stochastic, discovering things that you never knew were related, because now you find new clusters, new affinities, new commonalities that you discover things that you never knew before. You go back and either
Redefine
develop
it.
new models, or you define some of those predictive models. So it's very iterative to your points, but ultimately you start with that baseline of what you know and iterative.
You start with the birthing point and you go from there. And it is an evolutionary process with large data. Yes, with small data, yes and no. But with large data, it absolutely is evolutionary.
I had personal experience that someone came to me for advice, and I said, listen to me, but I don't know why they asked me. And I said, whatever you do not write your requirements for a year. They thought I was crazy. And as I grew up, so to speak, I found out the reason they're writing the data requirements not because they want to, because, as you said, the decision makers are saying, well, how can you apply that requirements? And once the requirements were written, it would take a year to undo them, so they were stuck in that mode. And then they found out the things that they weren't there, and they just created all these cliches to do things. So there's a serious problem with doing things the right way and having decision makers that don't understand that you really need an interactive process.
Exactly. Thank you. Exactly. So know where your bottlenecks are and the physical limitations of the hardware. You know, do you have a slow I/O handler? What's going on? Know the limitations in the way your database is designed. Now, it's less an issue now because of the differences in the structure of the DBs. But in the old days, you had things like file locking versus row locking versus a table lock or a column lock. And you could lock everybody out of the system for days and days and days if it was designed wrong. It's less an issue now. Now it's more about the threading. Have you got enough memory? Can you swap in the space? Can you set it up dynamically so that you're getting the space allocation you need to load the data and process the data in an effective way? And know when your operating system is going to start thrashing. Because the minute it starts thrashing, you're stuck. You know, you're going to be stuck for a long time.
Hardware very much of an issue nowadays anyways because the price is so low and stuff.
He would be better to answer that question than I am.
The answer is, right now you can balance workloads, you can literally go on, processor goes out, and the router automatically goes to two other servers. So we actually have disposable hardware.
That's what I thought. You can buy it for pennies on the dollar almost.
Yeah, we're running systems with 2 to 5,000 servers any given day. One goes out, it's automatically moved over, and the old processors just get canned. They're not doing fixing.
Pay attention to the legal requirements as well. That's a factor in what you design because it's going to be different for every state. It's going to be different for every country. There are legal limitations. This was actually a really interesting, and it's not big data per se, but it's big data within its field, okay? They had a situation where this particular group had a whole stack of PC users that were logging on for a scientific experiment. And they basically toasted the system because they had almost 4 times, between 3 and 4 times the load that they needed. You can go to a lot of systems that are out there that will say that they have the correct design for you when they don't. And if you don't know enough about the process or you don't have access to the correct decision makers or the correct support for your decision makers, you're not going to go to the right place to get the kind of support that you need. And that makes a huge difference. What data will you dump? You know, how much space do you have? If you can, dump what you can. 1, you're going to be getting more. 2, things run in cycles. So you will get the information again in most situations. All right? You may not get the tendency as fast, but it runs in cycles. And you can also define a limit in terms of the period of time of storage that you want to do it, and you can convert your storage to various different types so that you still have data accessibility, but you don't have to keep it in your shop. Okay? What are the limitations of the hardware platforms and the network structure itself? Because that's a factor. And that's a factor in any shop because of the accessibility to who they're trying to talk to. Most people don't have a super high-speed computer in their back room. They're accessing an IBM server. They're accessing through one of the SAS groups. They're accessing through one of the big data processing groups. And if they don't understand the limitations of their own network structure, that acts as a boundary condition in whether or not they can process the data that they need. If they don't define the needs of the business closely enough, they're not going to get the actual data that they want. If they don't understand the sizing and the volume of the data properly, they're not going to get the correct processing platforms, and they're not going to understand the shape of the data in the final evaluation. This is a hospital system with 50 hospitals. The average throughput, you're talking about between 400 and 500 beds per hospital. You're talking about teams in any particular group, in any particular ward situation, so that you're talking about conservatively, you know, somewhere around 1,500, 1,800 employees in any particular hospital setting, okay? And you're taking data on these patients, some of them almost continuously, all right? So you're talking about a fairly good-sized chunk of data. Now, it's not super, super massive data like some of the things, but it's a reasonable amount of data that you're working with. This particular hospital group went to PC servers, okay? Decided on tiered support because they wanted the docs to be able to use the PCs. They bought a mid-range database project, and they died a very deep and very serious death, okay? Because nothing was sized correctly. Absolutely critical, especially in a medical environment. So programmers, a key piece, don't understand how to use the software effectively for the chip, don't understand the stacking, don't understand how to optimize writing the code to make the best use of the compilers. And I have to talk about that from the point of view of actually being a dinosaur, okay? I wrote machine language, so I'm a bigot that way. I think that every computer programmer should learn to write machine code for their chips.
Isn't it true that a lot of the programs are making the same damn error for maybe 30 years? For example, Buffalo.
Oh, yeah.
You see the Buffalo program. They don't seem to know how to
They don't know what a stack is, and they don't know what a heap is. What do you want?
Thank you. Thank you. Yes, exactly.
One last quick remark, but I want to do it.
Okay.
Your talk entirely differently for the DNA days.
Let's see here. This is Wolf Geiger, who is fabulous, and I don't know how many of you know him, but he's an utterly decadent, marvelous. Wolf Geiger and Bill Malloy and Charles Irby developed the whole concept of metadata with our team, and just amazing, brilliant, brilliant, brilliant people. Data is only good as the format in which it's presented to the person who has to use it. If it's not in a format that they can use, there's no point in spending the time to do any of the processing. That's the single most important thing. Thank you.